Hi guys, we're going to talk about the concept of limits today, and we've talked about them kind of informally in the past. For instance, when we've had a quadratic, any kind of function, I guess we'd say, we can talk about limits. So here's my graph, and we can say the limit as x goes to infinity of this particular function, and I don't know what the function is. I want to know what the value of as x goes to infinity. Well, as x goes to infinity, my function is going to positive infinity. If I want to say as x goes the limit of my function as x goes to negative infinity is positive infinity again on this particular function. Now I can also say, let's see, here's 1, 1, 2, 3, 4. The limit of this function as x goes to 1, well, as x goes to 1, my function is going to 4, I've decided. So the idea of a limit, and it's a little hinky, the limit gets really close to that value of 1, but it never quite gets to the value of 1, because if it did, we'd say, what is f of 1? Well, in this case, f of 1 is also 4. Sometimes they match up. Sometimes they don't. We're not going to get too thick into limits, but if you're going into calculus, calculus is all about limits, so you really need to see it there. A couple ways to find limits. The first one is graphically, and that's what we've done so far in class. So here's my function, and I want to know what the limit of this function is as x goes to 2. Well, as x goes to 2, my function goes to 7. So the limit of that function as x goes to 2 is 7. Now you can say there's a hole there. Well, if I asked you what is f of 7 in this case? Well, f of 7, it's a hole, so it is undefined. So in the little drawing I just did, we had the value at this spot. In this example, we don't have a value at this spot. We still have a limit, but we don't have a value. Don't get too worried about it. We're not going to get too ugly about it because we're not face-to-face. If we were face-to-face, we could get a little bit uglier. There's a couple of ways to find limits. The first one, and the easiest one, is direct substitution. Negative 1, I'm going to put negative 1 into this function. Well, negative 1 squared plus 2 times negative 1 minus 4. So 1 minus 2 minus 4, and that equals negative 5. So the limit as x goes to negative 1 of that function is negative 5. And I could graph that and find that as well. What about number 2? Well, the square root of 3 times 2 minus 2 equals 6 minus 2 is 4. So the square root of 4 equals 2. So if I graph that, I'd be able to bear that out. The only problem with graphing is sometimes we're not able to tell, and we've run into those problems in class. So another way we could look at this, if I still tried to approach this by substitution, and if I put in a 0, I'd get 4 times 0 squared minus 5 times 0 divided by 0. Well, that doesn't help. But if I factor out an x, I'm going to get 4x minus 5 divided by x. And notice that my x's in this case are going to cancel, and I'm left with 4x minus 5. So if I say the limit as x goes to 0, well, 4 times 0 minus 5 equals negative 5. So I was initially kind of discouraged, but then once I factored, I found out that I do have a limit. So all is well there. The same thing on number 5. If I put negative 7 through, I'm not going to, but I might come up with, if I put a negative 7 through, I'm going to come up with a 0 on the bottom. So that's a problem. However, if I factor that, let's see, 2x and x, 7 and 1, positive and negative, over x plus 7. And now I can see that those factors cancel. So now I want the limit as x goes to -7 of 2x minus 1. Let's see, -7 times 2 is -14, minus 1 is -15. So initially, with substitution, I had a problem, but I could factor that, and all is well. Number 7 says rationalize. Well, that's a little ugly, it looks like. Let's see, usually we do this on the bottom by multiplying by the conjugate, but we could do it on the top. X plus 5 plus the square root of 5, top and bottom. This is a little unusual. We don't really run into too many of these, but we'll go ahead and do it just for kicks. So let's see, if I multiply up on top, I'm going to get x plus 5 minus 5, and then on the bottom I'm going to get x. You've missed that bell, haven't you? So let's see, clean it up. I'm going to get x over x times x plus 5. Okay. Oh, look at this. Now my x's cancel. And I've got 1 over the square root of x plus 5 plus the square root of 5. And now if I go the limit as x goes to 0, and if I evaluate that, I'm going to get 1 over the square root of 5 plus the square root of 5, 1 over 2 square roots of 5. And this would be a case where if you graph it, and I did just for kicks because I'm a math teacher, if you graph it, it looks like that. I can even see that blue line in there. Well, that doesn't really help us. So if I go and look at the table, at 0, I get an error message, but it's 0.223. So I'm going to say if this is 0.2237, 0.2235, I'm going to guess that this is 0.2236, approximately equal to. So, but of course you know what a stickler I am. I would want that exact answer. All right, let's do a couple of more examples. I set this up on the classroom, and I also gave you the key to it. And just take a look at them, and they tell you substitution. So those are all pretty straightforward. If I go down here, determine the limit if it exists. Hint, hint, hint. Let's look at number 7. If I put in 4, I'm going to get 4 minus 6. Well, that's the square root of -2. Guess what? That does not exist. If I put in, well, I can't cancel anything here. If I put in 6, I'm going to get 6 plus 6 on top, 6 minus 6 on the bottom, squared. And that's going to be 12 over 0. Well, that does not exist. So sometimes you're going to get those do not exists in there. I wanted to talk to you about this one because this one just doesn't feel good. And that is number 16. The limit of x as x goes to 0 of 10 sine x over 6x. Now we're not going to do much with trig here, but this is a straightforward one. Think about the sine of 0. The sine of 0, here's a quick look at the sine curve. Well, at 0, the sine is 0. So I'm going to say 10 times 0. Over, put 0 in for x, 6 times 0. Guess what? You might be tempted to say, well, that's 0 over 0 does not exist. Now this doesn't feel quite right to us, but I'm going to cancel those zeros. And then I'm left with 10 over 6, which reduces to 5/3. And if you graph that in radian mode, that would bear out to 5/3. That's a trick. We don't do that often, but it's a trick. All right, that's what I got. So I put this on Classroom along with the key. Just go through them, make sure they feel okay to you. And then the back side of this page that I just got done doing, we're not going to get into this up here because that actually is the definition of calculus. But I want you to do 1 through 8 down there and submit those to me, please. All right, guys, have a good day.